Okay, welcome to Lesson 18 as we continue our discussion of scale drawings. We're going to be doing computing lengths from actual scale drawings. You're going to need for your materials, you're going to need a ruler with inch markings on it. And we're going to look at example 1 on your lesson worksheet. This first example has us build upon the previous lesson by applying scale factor to find missing dimensions. And this leads into a discussion of whether this method is the most efficient and whether they could find another approach that would be simpler. Let's work together to record responses and additional work on our lesson worksheet. Alright, so based upon the picture, what are the actual dimensions of the half court? Will the lot be big enough if its width is 25 feet and its length 75 feet? Remember, a reduction has a scale factor less than 1 and an enlargement has a scale factor greater than 1. So, what do you think? How can we use the scale factor to determine the actual measurements? Well, we can divide each drawing length by the scale factor to find the actual measurement. So we're going to start off by making a table. So here's what your table should look like. If the scale drawing lengths are 1 inch, 2 inches, and 1 2/3 inches, then how is that going to equate to actual court lengths? Well, it's going to be 15 feet, 30 feet, and 25 feet. So let's next determine the scale factor, K, which again is also the unit rate, and identify what X and Y represent. Remember, we're going to need to convert feet to inches first. So for our scale factor, if 1 inch corresponds to 15 times 12 inches, or 180 inches. Therefore, the scale factor is 1 to 180. So our K, or constant, is going to be 1 over 180. The X is going to represent our actual length, and the Y is going to represent the scale drawing length. So how can we use the scale factor to write an equation relating the scale drawing lengths to the actual lengths? Well, the scale factor is the constant of proportionality, or the K in the equation y equals kx. Or again, we can write that equation x is equal to y over k, or even k is equal to y over x. So is the ratio of the drawing length to the actual length. So for example, with numbers, if we want to plug numbers in, we can say that 15 is equal to 5 times 3, which is also equal to 3 being equal to 15 divided by 5, or even 5 being equal to 15 divided by 3. Notice the relationship between all three of these equations. So we're going to use the equations to find the actual feet needed for the court. So let's take a look at the actual length. If y is equal to 1/80th times x, then 2 inches is equal to 1/80th times the actual court length. Well, if we have 1/80th times some number is equal to 2, then in order to find this number, remember we have to do the reciprocal, which is divide. So this is really 2 divided by 1 over 1/80th. Well, when you do that, now what you're actually doing is 2 times 180, and that's how they get 360 inches. And because we measure the actual length in feet, we're going to convert 360 inches back to 30 feet. And then when you do the same thing to find the actual width, y is equal to 1/80th times x. Well, if the actual width is 1 2/3 inches, we're going to again, and they show it here, multiply by 1/80th or 180th over 1 times 5/3, which is 1 2/3, and that gives us 300 inches, or the equivalent of 25 feet. So the actual court measures 25 feet by 30 feet, and this answers the question, yes, the lot will be big enough for the court Vincent plan. The court will take up the entire width of the lot. All right, so let's take a look at example 2. After reading the problem, let's look at the word scale. Where have you seen this term used? Well, you've probably seen it on the bottom of a map or a blueprint. It refers to a type of ratio. 1 centimeter represents 20 meters is one example of a ratio relationship. And the ratio, 1 to 20, is sometimes called the scale ratio or scale. Why can this not be called the scale factor? Again, remember the definition of what a scale factor is. Well, the scale factor has to be scaled, a scale drawing in scalar distances between the measured same units. For instance, centimeters to centimeters or feet to feet. In our previous example, it was 1 centimeter is 20 meters, so that cannot be a scale factor unless you convert the meters to centimeters. So do we always need to use a scale factor in order to find actual measurements from a scale drawing, or could we just use the given scale ratio or scale? Well, take a few minutes to try to find the actual length of the garden. Give your answer in meters, and when you are finished, you'll be asked how you found your answer. So go ahead and pause the video and answer the question about the length of the garden. All right, you should be done with the garden question, so let's compare your answers. If the scale is 1 centimeter and the actual would then be 20 meters or 2,000 centimeters. If the length is 8 centimeters, then the actual length is 160 meters or 16,000 centimeters. And if the width is 4 centimeters, then the actual is 80 meters or 8,000 centimeters. So here's method 1. Here's one way you can figure it out using the given scale. So if 1 centimeter corresponds to 20 meters of actual length, our K could be 1 over 20. So when we do this, 1/20th, we would get 8 equals 1/20th times x, in which case x is equal to 160. And that is in meters. Okay, to find the actual width, you divide the actual length by 2, since the drawing width is half of the length. In this case, the actual width is going to be 80 meters. So in this case, we can do centimeters to meters in this respect. Now here's another way we can do this. This is method 2. Let's say that if we use a scale factor, we use 1 centimeter is to 20 meters or 2,000 centimeters. So notice what happens with our ratio. It's 1 to 2,000. Well, when we do that, we end up with y is 16,000 centimeters, which if we need to convert it back to meters, centimeters, 16,000 centimeters would be 160 meters. And then the same thing with finding the actual width. 8,000 centimeters would be 80 meters. So in essence, you could figure it out either by using the scale factor or by just using the scale. All right, so let's take a look at example 3. See if you can solve this on your own. Use your ruler to measure the length and width in inches, and make sure you have the following. You need to have a table identifying what is the x and what is the y. You need to find the constant k. You need to create an equation in the form of y equals kx. And use the equation to find the actual length and width. All right, so once you are done with that question, go ahead and continue the video to see the answers. All right, so for the graphic design on the tablet, here is an example of a table, the picture being y and the actual advertisement being x. Means that if you did it in inches to inches, this is what they would look like. So finding the constant of proportionality, k is 25 hundredths to 1. the K would also be 1 to 1/4 if you wanted to do the same as a reduction. So 25/100 to 1 is also 1/4. So our actual equation is y equals 1/4 x. And then you start plugging in the length. If 1 1/2 is equal to 1/4 x, then you would multiply each side by 4, and you would get 6. And to find the actual width, you would have 4.5 inches. So the tablet will be 6 inches by 4.5 inches on the actual advertisement. And this table helps you out with that. All right, is it always necessary to write and solve an equation to find actual measurements? Well, the actual measurement can be found by applying any of the three relationships. Y equals kx, x equals y divided by k, or even k is equal to y divided by x. Try any of these approaches in the next exercise. So here is exercise 1. Identify the following big ideas to address as you solve the problem. We need to find the relationship between the lengths in the scale drawing and the corresponding actual lengths. Use this relationship to calculate the width of the actual mall entrance. Compare this with the width of the panels. And remember, the map distance of the mall entrance should be noted so that students would not need to measure that. And determine what unit to use when measuring. Look at the given scale. When you're done with exercise 1, continue the video. Alright, so you should be done with exercise 1. Let's see what you came up with. So, answering the following questions, find the actual distance of the mall entrance and determine whether the set panels will fit. So here's step 1. The relationship between the lengths in the drawing and the lengths in the actual. The scale will be 1/8 inch over 4.5 feet, or an equivalent ratio of 1 to 36 inches to feet. The scale factor calculations, if you were to do that, 1/8 to 54 inches to inches. So if we take 1/8 times 8 and 54 times 8, because again we want to get rid of the fraction here, that means that the scale factor is a 1 to 432nd reduction. Okay, for step 2, find the actual distance. So given the scale factor, or given the scale, 3/8 times 36 over 1 equals 13.5 feet wide, or using the scale factor, 3/8 times 432 over 1 means that it's 162 inches, or if you convert that to feet, 13.5 feet wide. So yes, the set panels will fit laying flat through the mall entrance. So what is the scale factor and what does it tell us? Well, the scale factor is 1 to 432. Each length of the scale drawing is 1/432nd of the actual length. The actual lengths are 432 times larger than the scale drawing. Notice that last statement is just a reciprocal of the previous statement. What is the reciprocal of 1/432nd? Well, it'd be 432 over 1. Alright, so let's go ahead and summarize. What does the scale factor tell us about the relationship between the actual picture and the scale drawing? It gives us an understanding of how much bigger or smaller a scale drawing is compared to the actual picture. How does a scale drawing differ from other drawings? Well, in a scale drawing, there exists a constant ratio of scale drawing length to actual length, whereas other drawings may not have a constant scale ratio between all the corresponding lengths of the drawing and the actual. All right, we'll see you in class.